Alright, welcome everyone. This is our talk today on managing your OpenStack resources with Kubernetes using ORC, which is the OpenStack Resource Controller. So just to introduce ourselves, my name's Finucane.
André.
We have between us probably about 20 years of working on upstream OpenStack and maybe 10 or more years. Accumulated, yeah. We're not that old. And maybe 10 years working on Kubernetes, so we have a lot of experience with both of the products. Our individual backgrounds, I've done a lot of work on the client tooling over the last few years, so SDK and OpenStack client.
I have worked mostly on the deployment of OpenStack.
And we're both maintainers on Capo and Go for Cloud and a variety of other OpenStack or OpenShift and Kubernetes on top of OpenStack components. So we've been around the block basically when it comes to this stuff. So to begin with, we're going to go into a lot more detail on this, but we're talking about a thing called OpenStack Resource Controller. So I assume most people in here are familiar with Kubernetes at this point and kind of the basic design concepts around it. What OpenStack Resource Controller is from like your 10,000 foot view, set of controllers and a set of custom resource definitions for managing your OpenStack resources. Because it's built on top of Kubernetes and it uses Kubernetes style APIs, it has the same declarative API that you'd expect from Kubernetes as opposed to the more imperative style API that you get from OpenStack. It is installable within your typical Kubernetes clusters, so it is Kubernetes native. And it is built on top of Go for Cloud, which is the OpenStack SDK in Go. Again, we're going to go into a lot more detail about this, but this is a very high-level overview with that's stuff written on the board of the kind of things that we are able to model in ORC as it currently stands. It's still very early days for this as a service, but this idea of having objects that exist that have their Kubernetes representation and mapping those into OpenStack so that we can achieve a particular desired state in a fairly declarative manner. The user creates the ORC objects, they never actually interact directly with the OpenStack API. ORC is responsible for managing the lifecycle of these objects on your behalf.
Okay, so now if we want to have a more detailed look at ORC, we'll actually go back in time to the beginning of the project, and here just a quick history about ORC. So ORC is the brainchild of Pierre Prinetti, who was supposed to be presenting with us today, but couldn't make it, unfortunately. It started with a very basic question. So what if we use Kubernetes to manage your OpenStack environment? So Pierre and a bunch of engineers from Red Hat who were interested in the question gathered and started working on a prototype to validate the idea, make sure it's viable. And they worked on a project that does that. Then maintainers of the cluster API provider OpenStack, Capo, and so this project, and we're looking for a solution that allowed these kind of things to manage their OpenStack images in Capo. So we moved the project to Capo. We developed the existing structure of ORC, so what ORC looks like today. We changed that structure in Capo. And once we were happy with the functionality, with the structure, we decided to split it out from Capo and use it as a standalone project again. So we tagged that as a 1.0 release. So exactly the code that was in Capo. We only had the image controller, and continued working on that project, adding more controllers to allow deploying servers, image, a lot of things. And we had a 2.0 version soon after. And so why did we make a new major version. So the reason is because we try to be very strict about semantic versioning, and when working on this new additions, so we discovered that the API was not correct, meaning from a Kubernetes point of view. So we had to make some non-backward compatible changes to the image API, and hence the major bump there. And so what makes ORC? So what was the decision that the developers decided for the projects? ORC is a Kubernetes application, and well, as such, we try to follow the Kubernetes convention as much as possible. We also wanted to have dependencies being integral part of the project from the start. So we have dependency management when you create resources, when you delete resources. We'll talk a little bit more about that shortly. We also wanted ORC to be deterministic. So there are some operations in OpenStack that by nature are non-deterministic. So for example, when you create a floating IP, but for everything that can be deterministic, we try, or we want in ORC to have, to use that path. So just to give you an example, so when you have a network that has multiple subnets and you want to create a port on that network, OpenStack will pick a subnet for you. You don't know which subnet it's going to pick. It's a surprise. We clearly don't want that in ORC. We want the user to specify which subnet exactly you want your port to be created on. Another characteristic of ORC is that we try not to make any API call that is not necessary. The only occasion on which ORC will make API calls to OpenStack is when you create, you update, and you delete an object in Kubernetes. So by nature, we do not pull OpenStack. This might change in the future. Again, we'll talk about that. But right now, this is the decision we've made. So if you want your resource to change in OpenStack, you'll need to modify your Kubernetes objects. So yeah, what that means is that if you make change to the OpenStack resource externally, ORC will not notice this change. So also, so you have the ability in ORC to manage dependencies. So the way you do that is so referencing resources from other resources. And by choice, we wanted to have reference by name, so by Kubernetes name only, and never by OpenStack IDs. So that means that if you want a dependency to be reflected in ORC, you need to have the object existing in ORC beforehand. So that could be a problem if ORC was not able to import resources that are managed externally. So for that reason, we have a distinction of managed and unmanaged resources. So managed resources are the one for which ORC is going to control the whole life cycle of, so creation, update, deletion. And unmanaged are the one that typically are created by the admin, so the shared resource of the cluster, so provider networks, images, flavors, these kind of things. So things that you as a user won't create for yourself. So the way you do that is you import this resource in ORC with an import filter. You will see that. And you mark the resource as unmanaged, meaning that ORC is not going to make changes to these resources. So let's have a look at simple examples of ORC objects. So this is an ORC object. From a glance, so can you tell what it does? it should be easy. So let's break it down. We have the kind being a network, so that means that we'll identify which controller is going to be responsible for this resource. So here that would be the network controller of ORC. This is the Kubernetes object name, so in that case, minimal network. Here, this is reference to the OpenStack credentials. So these are stored in a Kubernetes secret. Here, the secret is named OpenStack Cloud, and it references a clouds.yaml entry named OpenStack. So all objects in ORC have these cloud credentials, right? This is a managed object, meaning that ORC is going to create the object if it's not there already. And the resource spec here, you can see it's empty, and this is actually valid in ORC. So this spec is valid because in this particular example, when you want to create a network in OpenStack, the only required field that you need to provide is the name of the network. And if you don't provide a name in the resource spec, we are going to use the name of the Kubernetes object. So this whole YAML file is actually equivalent to this OpenStack command. But there is a big difference. In that case, we now have Kubernetes ensuring the consistency of the whole system, making sure that your resource is created, and retrying when it's not the case, and retrying when the resource does not match the specification. So on to a little bit more complex example. So this time we are operating on a subnet. And you can see here the network graph. We are referencing the network that we just created earlier. We're adding more required parameter for that spec, so more fields, so IP version and the CIDR. These are necessary when you create a subnet. And again, this is the command it's equivalent to. And again, there is a pretty big difference, and that Kubernetes will now manage the dependency for us. What that means is, if you don't have the network object, so the minimal network object created in ORC with a status of available, then ORC will not even try to create the subnet. It's not going to send any API request to OpenStack to create the subnet. And it also works so in the opposite direction. So now that we have a subnet created on that network, if you try to delete the network in Kubernetes, ORC will notice that there are still subnets that are allocated on that network, and will prevent the deletion. So it's not even going to send a request to the OpenStack API to delete the subnet. Only to delete the network. Only when every subnet, every object that depends on that network are gone, that Kubernetes ORC is going to send the request. And the last example that we'll see today is how we import resources in ORC. So again, that's subnet, and this time we have an unmanaged object. So this one is going to be managed externally. And our import filter. So here you see we have a filter where we are filtering by name. This is not really advised in general, but here for this demo, for this presentation, for the sake of simplicity, we're just going to filter by name. You might want to add more filter in production, because names are known to be non-unique in OpenStack, so this could match multiple resources. So what happens when you have a filter that matches multiple resources? Well, in that case, ORC will return a terminal error, and it's not going to do anything until you modify the object to fix the filter.
Quick question, when you look at the status of the objects, then it's in some kind of a state where it says, yeah, well, it's pending or something until...
When it's waiting for the resource to be available, for example? Yes. So it will tell you that there is one dependency, for example, that is waiting for a state to be completed.
Okay.
Yeah. And now, Steven, back to you.
So how can you actually go about using this? So we've been working on this for the last over a year anyway. And we've gone through multiple versions, as Martin alluded to earlier. So there's a couple of different ways you can go about using this against your existing OpenStack clusters. The first of these is probably the most obvious ones based on the examples Martin just went through, which is the GitOps, your typical GitOps workflow. So we have previously given demos, or rather a colleague of ours has previously given demos of integration of this, of ORC with Argo CD, for example, as a way of declaratively declaring your OpenStack API or OpenStack infrastructure, and making sure that any changes to that infrastructure, you reconcile things accordingly. You change your definitions in ORC, and it automatically goes and updates everything on the back end for you. This is a very high-level overview of what that kind of classical structure would look like. It's your typical control loop that you'd expect from a Kubernetes controller. That is what ORC is providing for us, and that is running and reconciling your definitions as they exist in ORC against what's actually on the underlying cloud. That can be driven by an end user. It can also be driven by something like Argo CD, which in turn will be driven by the end user. Another option is to go and use this as an orchestrator. So you would go and define what you want to exist in your OpenStack cloud. You throw all of that at ORC, and you allow ORC to go and reconcile everything and create things in the right sequence for you. This benefits, ORC gives you the benefit of a declarative API, the ability to manage dependencies. And again, as Martin said, the dependencies are mapped at an ORC level, so we're not so reliant on the underlying services providing that kind of that dependency management for us. Naturally, you can layer on as much complexity as you like here, and it will automatically go and reconcile that, so you can build up arbitrarily complex applications. And you could then, as you would suspect, you could go and use this as a replacement for something like Heat or large Ansible playbooks or whatever. And then the third and final use case that we'll cover here today is to use this in an embedded fashion. So we've given examples of actually creating blobs of YAML effectively and throwing them at an already running controller. You can also go and embed ORC in an existing controller that you have. So we have, as Martin said, we have been using ORC in Capo for the last few releases. We have also used it in products that Red Hat have called Hypershift, where in both cases, we're using it to manage the lifecycle of images, which turns out to be a use case that there's a lot of corner cases effectively with the Glance API when it comes to creating and updating images. The advantage of having ORC available and using it as a library embedded in your project is you get to effectively forget about a lot of the stuff that ORC will give you for free, so all the dependency management. It will do all of that for you, and it will do so in a hopefully pretty reliable and fairly well-tested manner. And this is an example, this is code that we've actually taken from the Hypershift operator. You were saying that we don't create images within Capo, but we do use it to retrieve images and confirm that they actually exist as we expect them to. So now a little bit of a comparison with some of the other Kubernetes style OpenStack orchestration tools.
Right, so this is not really a competition, but more have a look at the field, so what others are doing. And as you can imagine, so every major cloud platform has a project that is more or less equivalent to ORC. AWS has a project called ACK, Azure has one called ASO, GCP on KCC, and VMware is a little bit different. So the scope of their project is a little bit different. I think it only provision VMs, but I'm not too sure. But yeah, so at least for Azure, AWS, and GCP, so they have very, very similar projects. They are more mature than ORC, and so for us, that would be an opportunity to look at what they're doing. So AWS, so ACK, for example, does something that is drift detection that will periodically check that the clouds, the results they have on the clouds are not changed since last time they saw. So I think by default it's every 10 hours. And so it's not too hard on the cloud. So it's not going to bring your cloud down by polling too frequently. So this might be something you might be interested in to implement in org as well. They do as well allow multiple instances of your controllers. So for even higher availability, we don't do that in org yet. But again, something we might want to take a look. And as far as I know, it's a project. So they generate part of the API and part of their controller from open API specs. So this is something we're very interested into. Actually, Steven and Autumn, right there, have a break right after this one, who are going to talk about the state of open API progress in OpenStack. So if you're interested, I think it's above. Follow Steven and Autumn. Yeah. They will lead you to the right room. Okay. So yeah, the major cloud platform have a similar projects. There is also another project that some of you might be familiar with. That's called Crossplane. That again does more or less the same thing. So Crossplane has a bigger scope. It's a bigger project, it's a CNCF project, has a big community, and they propose something that is, in theory, is cloud agnostic. But in reality, every provider will have their different API, and using Crossplane over something like ORC, so when you need to move resources from AWS to OpenStack, for example, you would still have to rewrite everything with the right API. So that doesn't provide a real clear-cut advantage over using something like ACK plus ORC together. So before starting ORC, we also looked at Crossplane, and we saw that, well, the OpenStack provider in Crossplane is built on top of Terraform. While this can work, we found it to be a little bit complex. In org, we made a choice to talk directly to OpenStack using the Gopher Cloud library. That makes it a lot simpler for us to implement missing fields, to fix bugs in Gopher Cloud, and then have them directly usable in org. So less layers, easier for us to work with. So just in terms of features, so org would be, crossly speaking, the equivalent of Crossplane managed resources. So, but Crossplane does more things. And one of the things that Crossplane does is composition. And there we're lucky because there is a new project called Crow, for Kube Resource Orchestrator, I think. So a project that was started by AWS, and now that is under the Kubernetes SIG cloud provider. So that's a Kubernetes SIG, meaning it's also a CNCF project. And for us, that's perfect. We like this approach because, well, that fits better with the Unix philosophy of doing one thing and do it well, and also, you know, the modularity that comes with it. And so, where is org now? So we have controllers for most of the core resources. So the implementation might not be complete, but no, you can already use that. So we have projects that use it in production, for example. the way to contribute to org is also, well, as of recently, more easier because we have now a generator for new controllers that does 95% of the work.
Easily, yeah.
Yeah, so yeah, really streamlines creating new controllers. The team, well, is rather small. So compared to the big projects, yeah, clearly our team is small. We are not moving as fast as we would like, but we're still moving forward. And well, both Steven and Art are Gopher Cloud maintainers. So as we work on org, so we find new bugs in Gopher Cloud. So things that are missing in Gopher Cloud, for example, or things that when you have a set, when you can set a field but you cannot unset it, that would be a problem in org. So we are fixing these things as we go. And well, this is actually a slide for you. So how can, well, where does that fit for you? So well, try org, you provide feedback, you see if that fits your use case. If you see controllers that you would be interested in but don't have the features that you need, please talk to us. Contribute the code, that's even better. Like we say, it's pretty easy to get started with. We accept new features. The community has been asking for Helm charts. We don't have that yet at the moment, and we are not all experts. So yeah, if anyone knows Helm, please join us. If you want to contribute, great. And so we're in the Gopher Cloud channel on Kubernetes, on the Slack Kubernetes. And yeah, the website k-or.cloud that has all the documentation to get started. So that's about it. Yeah.
Yep. So we've got a minute, I think, for questions, and then I need to run.
Here's one. How do you plan on handling like cascading deletions? Let's say you create a project, you create a network subnet, and then delete the project resource. Then what's the intended outcome?
So if you want to delete a project, if you still have a resource that depends on this project, it's not going to be deleted.
So you have a finalizer on it.
Exactly. We have a finalizer, and until all the finalizers are done, the project is going to need to stay there.
We're around all week. I'm going to run if that's okay. We're around for the rest of the weekend. Feel free to come and ask either of us if you have any questions. We'll be happy to take them.